right, good morning, boys and girls, or good afternoon, whenever. Today we're going to talk about prime factorization. We've been talking about prime numbers, and we've been talking about factors of composite numbers, and today we're going to find the prime factors of composite numbers. And for a little bitty review, it says, given the number and its factors, tell whether it is prime or composite. Now, the definition of prime is that it only has two factors, one and itself. That number is prime. Remember, we go through all the divisibility rules. If it's an even number, it's divisible by 2, so it's composite. Except for 2. 2 is the only even prime number. So if it only has one in itself, then it is prime. If it has more than just one in itself, it is composite. Now, we're going to learn how to do prime factorization. And I'm going to use the number 24. It is not on this list. It's not on either side, but I'm going to show you how to do it. You put 24 at the top, and your goal is to find what times what is equal to 24, and you keep doing that until you have nothing but prime numbers at the bottom. And you can start with any prime factor pair. So we're going to start with 2 times 12. Now, 2 is prime. Remember, your prime numbers 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. We're supposed to get those memorized. So 2 is prime. I'm going to circle 2 because it's prime. I don't have to do anything else with 2. 12 is not prime. So I think to myself, what times what is equal to 12? So I'm going to go, well, I know 2 times 6. And again, 2 is prime. It's the only even prime number, so I'm going to circle it. We don't have to do anything else with it. 6 is not prime, so I'm going to think what times what is equal to 6? 2 times 3. They are both prime. 2 and 3 are both prime. So that is my prime factor. If I do 2 times 2 times 2 times 3, my answer will be 24. Let's check it out. 2 times 2 is 4. Remember your order of operations. Then 4 times 2 is 8. We work from left to right. And then 8 times 3 is, guess what, 24. So if your number comes out the same, you know you have done it correctly. So the prime factorization is 2 times 2 times 2 times 3. Notice you never use 1. If you use 1, if I'd used 1 here, 1 times 24, I wouldn't have gotten anywhere. The goal is to break it down into its smallest factors, and if you use 1, you're not breaking it down, because you wind up with the same exact numbers. Now let's do the number 20. So I'm going to use, well, let's do 24 again. This time I'm going to use a different factor pair to start with. I want to show you it doesn't matter which factor pair you start with. Again, we are never using 1. Forget about 1. Remember, we are not using 1. So what times what is equal to 24? Well, 3 times 8 is. And 3 is prime. It's one of our prime numbers. Is 8 prime? Nope. It's even, so I know 2's going into it. It goes 2 times. 2 times 4. Now I know 2 is prime. It's the only even prime number, so I'm going to go ahead and circle it. Is 4 prime? No. 4 is 2 times 2. Now, 2 times 2 is prime. So I have 3 times 2 times 2 times 2. 3 times 2 times 2 times 2. Well, look over here. 1, 2, 3 twos, 1, 2, 3 twos, and my 3. So they are identical, but let's go ahead and check it out using order of operations. I'm going to work from left to right. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. Now guess what? That's not the only factor pair for 24. There's another way, and we're going to see if we get the same answer. I know 4 times 6 is 24. Neither one of those are prime. So I know 4 is 2 times 3. 2 times 2. And 6 is 2 times 3. Now they're all prime. 4 is 2 times 2, both prime. 6 is 2 times 3, both of these are prime. And so we get 2 times 2 times 2 times 3, which is exactly what we got up here. So my point is, no matter which two factors you start with, if you do it right, now I know some of you struggle with your facts, and here we go again. This is going to be, it'll be a little bit harder if you have to struggle with what times what is 24. If you had your facts fluent, then this would be pretty easy. A lot of my students like it. So let's check it out. 2 times 2 is 4. Remember, left to right. 4 times 2 is 12. Well, let's do this out. 4 times 2 is 8. I talk about not knowing your facts. 8 times 3 is 24. And we get what we started with. Now let's do 20. And I know 2 times 10, because it ends in a 0, tells me 10's going into it. 2 times 10. And I know 2 is prime, so I'm going to circle it. 10 is not prime. It ends in a 0. I know 5 will go into it. Remember, we can never use 1. 10 is 2 times 5. And I'm going to circle 2, and I'm going to circle 5, because they are both prime. So the prime factorization for 20 is 2 times 2 times 5. Now, why am I learning all this? Well, our whole goal, and as I told you from the very beginning when we started factoring, when we do fractions, you're going to have to simplify every single fraction. You're going to have to put it in its lowest terms for the rest of your life, pretty much, or you'll get it wrong. And so if I have the fraction 20 over 24, and I'm asked to simplify it, one strategy is to list out the prime factors of 20 here, 2 times 2 times 5. And then the factors of 24, draw our fraction bar, 2 times 2 times 2 times 3. And now we factor out from top and bottom common factors. So I can factor out, I can get rid of that one and that one. They go together. That 2 cancels out that 2. That 2 cancels out that 2. And what I'm left with is 5, and then 2 times 3 is 6. So your fraction simplifies to 5/6. So that's one strategy. Remember, we talked about yesterday finding the greatest common factor, which is 4. 4 times 5 is 20. 4 times 6 is 24. We factor out our 4s. And 20 over 24 is 5/6 in its lowest terms. So that's our whole goal here. I'm going to do 630. Wait, the hardest one, I think, is 630. All right. I know 10's going into it because it ends in a 0. And I know 10 times 63 is equal to 630 because all you do is add your 0 to the back. And I know 10 is not prime and 63 is not prime because 6 plus 3 is equal to 9. That tells me 9 is going into it. And I know 9 times 7 is 63. Now 10 is 2 times 5. 5 I know is prime, 2 is prime, 7 is prime. How do I know that? I have them memorized. Is 9 prime? No. 9 is 3 times 3. A lot of people think it is because it looks prime because it's an odd number. Odd numbers are not necessarily prime. See, 63 is odd. It's not prime. So our prime factorization of 630 is 3 times 3 times 7 times 2 times 5. And we did it by breaking it down easy ways. And let me do one more for you, 625. And I know, let's see, 25 is going into 625. There are 4 25s in 100. So 4 times 6 would be 24 plus 1 is 25. 25 times 25 is 625. Let's see if that works out. 5 times 5 is 25. Put down your 5. Carry your 2. 5 times 2 is 10. Plus 2 is 12. Kiss, kiss, hug, goodbye. 2 times 5 is 10. Put down my 0. Carry my 1. 2 times 2 is 4. Plus 1 is 5. I add it together. Sure enough, it is 625. So 25 times 25 is 625. And then I know 25 is not prime. It ends in a 5. 5 times 5. 25 is 5 times 5. So the prime factorization of 625 is 5 times 5 times 5 times 5. 5 times 5 is 25. Times 5 is 125. Wait a minute. 25 times 5, pretend like that's a 5. It's a messy 5. There. 25 times 5, remember we work from left to right, is 125. And then 5 times 100 is 500. 5 times 25 is 125. 125 plus 500 is 625. And it worked out. All right, good luck.